Hey guys, good morning everyone, or well, good day, depending on where you are located. Um, Welcome back for the session number 2 for the Security Operations Analyst, the SC200. Today we have another couple of modules to cover. In the next 2 hours, I will cover partially some of the topics from modules 3 and 4 for the S200 curriculum. Let me start by showing you the topics that I'm planning to cover today within this SC200. So for today, for day number 2, for the next 2 hours in this session, we have for modules 3, mitigate threats using Microsoft Defender for Cloud. Name of the lessons, manage or cloud security posture management. Plan for cloud workload protections using Microsoft Defender for Cloud. Workload protections in Microsoft Defender for Cloud. Connect Azure assets to Microsoft Defender for Cloud. And for module number 4, create queries for Microsoft Sentinel using custom query language or KQL. We have topics for construct KQL statements for Microsoft Sentinel, analyze query results using KQL, and create queries for Microsoft Sentinel using custom query language. And for homework, you have to take and cover in Microsoft Learn the next modules or topics. For modules 3, mitigate threats using Microsoft Defender for Cloud, connect non-Azure resources to Microsoft Defender, remediate security alerts using Microsoft Defender for Cloud, mitigate threats using Microsoft Defender for Cloud, and for module 4, create queries for Microsoft Sentinel using custom query language. There's built a multi-table statements using custom query language or KQL, and work with string data using KQL statements. Modules 3 and 4 has lab exercises. So today, after the 2 hours and after the 30-minute break for the last 2 hours and a half for the session for the lab and Q&A, you will have enough time to get your hands on into the lab exercises for modules 3 and 4. And during that session, you can ask any question. Also, during this 2-hour session that I will present some content and include some demonstrations, you can also ask your question by using the Q&A tool within this On24 platform. Gerardo is the moderator for today's session also, and it is going to answer all of your questions. All right. I will just take a screenshot for this, the topics, especially for the homework one. And when we are at the lab and Q&A session, I will paste the image into the slide that I will use to present there, and you can take a look at the modules that you have for today there. Okay, so well, after that introduction, let's start with the module 3, mitigate threats using Microsoft Defender for Cloud. Just give me a second here to start. And let's take a look. We have a first lesson, plan for cloud workload protections using Microsoft Defender for Cloud. And let's start by explaining what is Microsoft Defender for Cloud. It is the Microsoft Defender is considered a 2 tools in one. It is considered our CSPM and as a CWP. CSPM stands for Cloud Security Posture Management, and the CWP for Cloud Workload Protection. So this is a service that can help to the security team to analyze the security posture of one or multiple subscriptions into a one or multiple cloud environments, not just limited to the Azure environment. And we can extend protection to the on-premise also. And for other cloud environments, we can see that there is the possibility to extend the protection to other cloud environments like AWS, GCP, GitHub, Azure DevOps, and so on. So that's why it has been receiving like a updates to the name of the service, because this was previously known as the like a year ago or a little bit more than a year, formerly as an Azure Security Center. And well, like a year or 2 years ago, Microsoft decided to consolidate all of the protection services, especially the cloud ones, to a Defender family, because there is Defender for Identity, Defender for Office, Defender for Endpoint, Defender for Cloud Apps, Defender for Cloud for protecting the cloud assets. Um, and well, just decided to remove the Azure, because in the past they were only available for connecting, let's say, with Azure subscriptions and with Azure resources on it. But now with the let's say but after extending the scope for the service for multiple clouds and to the on-premise, they just remove the Azure name, because now it's a Microsoft Defender for Cloud, basically. So with these two functionalities, the cloud security posture management, the service is actually helping us to uh, detect, first to start to mm, assess, discover the resources that we have for the many sources, the multiple environments, and based on policies evaluations from the Azure Policy Service and initiatives, the results for those policies uh, will be, for example, the non-compliant resources based on those policies. But the policies will be associated with standards. So Defender for Cloud is using Azure policies, and the Azure policies are going to be based on standards. And from standards, then we can find out examples of an ISO, SOC, PCI, HIPAA, and many others. So every standard will be represented by an initiative. And an initiative, it is a group of individual policies. So for every, let's say, for every best practice, there should be a Azure policy that the objective for that policy is for checking in if there are resources from that type. For example, a single policy can be checking in if a virtual machine has a network security group, if a virtual disk has encryption applied, for example. So the lack of compliance with that policy from that standard, from that initiative, it will generate as a policy result a non-compliant resource. And that lack of compliance, and if Defender for Cloud is following that standard, that should apply all those security best practices, because we decide to follow that standard, the lack of compliance will generate, as a result of the policy, a list of non-compliant resources. All of the disk that doesn't have a volume encrypted, then there will be a list of those resources on. The lack of compliance for those number of resources on it, eventually Defender will create a security score for that. So the lack of compliance for that, I will see that the points that I can get for making those resources to be in compliance, I will not receive those points. And at the end, the security score, the overall security score, goes on a scale from 0 to 100%. And if I have non compliant resources under my one or multiple subscriptions, of course, that my overall security score will never get or will never reach the 100%. So I will see something different. So that is how it works. So just give me a second. Also, if we can take a quick look at this Microsoft Defender for Cloud, and we can see the multiple pieces associated. We can find out as the Defender for Cloud as the name of the service. Usually, we need to, let's say, activate or enable the service, because by default, for example, into your lab environment that you activate yesterday or that you will activate today, the Defender for Cloud will not be active. And you just need to click on an upgrade option to activate it. Once that you activate it, you will stop seeing a lot of grayed outs into the left vertical menu. And once that you activate it, you will see that the number of subscriptions associated, it will be only one, your only one Azure subscription active. You can see that there is, onto your security posture, you can see an overall in the case that you have more than one subscriptions on different environments for other clouds, for example, and a security score eventually on it for your security posture. If we would like to see how Defender for Cloud works and what is its relationship with the policies and subscriptions and so on, you can go to the management menu and clicking on environment settings. And then you will start to looking at all of the subscriptions associated, and you have an option to starting connecting to other environments. Every ad environment will have its own step process to follow. For example, you just need an account details, selecting plans, configuring actions, and review and generate to create the persistent connection on. For the GCP, for example, there will be another assistant with 4 high-level steps: organization details, plans, configure access, review and generate, and eventually you will have a second or number 3 or more subscriptions on it. Something similar to GitHub, Azure DevOps, and so on. Now, because I only have one subscription, that I can just click on the subscription name, and then another sub-menu will open. Here on the main settings for Defender plans, I can see on which of the services the plan is turned on, or I can make a decision to turn it to on or off, because this is not just either you monitor all or nothing. It doesn't work that way, because we can specifically turn on the plan for a specific type of services, like for protecting only servers, or for checking in and check on the security posture and cloud workload protection for servers, for application services or web applications, for relational databases in platform as a service, for storage accounts, for containers, container registries, Kubernetes service, for Key Vaults, for Resource Manager, for DNS, and for Purview, Defender Cloud Security Posture Management, for example. We can set notifications too in the case that there is a recommendation trigger or some threat detected. Then with this configuration, it can send emails automatically to a group of users on it. And in this option, we can specify playbooks that we can basically create and associate logic apps to automate some process or automating workflows. With integrations and continuous export, we can make an integration to other Defender products like Defender for Cloud Apps to access like data here, and Defender for Endpoint. With the continuous export, we can specify all of the logs generated or all of the events like security recommendations, security scores, security alerts, and regulatory compliance to send these events or store it into a log and workspace or send it into an event hub, which is an event routing system or service that we can use to connect with a third-party security appliance or solution like a third-party SIEM, like a Splunk, for example, to create a continuous export pipeline, for example. And all of these options, well, all these exported data types can be connected in real time to the event hub and the event hub with the third-party solution outside of Azure, for example. In the case that we don't want it to use it, then this is going to be storing the information in straight to a login in workspace. And then from the workspace, we can run the queries that we need to create our own custom alerts, for example, if we want. Now, into this policy settings section, then we are going to check on what are the policies or initiatives that Defender for Cloud is following right now. Usually by default, when we just turn on the plan for Defender for Cloud, there is an initiative called ASC default. ASC stands for the old name of Defender for Cloud, Azure Security Center. So that is still the default name for that initiative. And that initiative is including 188 individual policies so far. But well, there is a default policy that is configured the ASC. We are not forced to follow this initiative all the time. We have an option to modify which policy do we want to follow by a list of the built-in initiatives, for example. If our organization is to follow the PCI DSS 3.2.1, the ISO 27001, the SOC TSP, we can take a look at another catalog of compliance standards or initiatives. If we are interested into the NIST, the Azure CIS, the CMMC at level 3, FedRAM, HIPAA, High Trust, Canada Federal PVM, UKO and UK NHS, NIST, and so on. We can just click on add, and we can add more than one. But at the end, what we are adding is just one or multiple initiatives. And if we understand that every initiative is our multiple policies, at the end, if I have 5 initiatives and hypothetically, each initiative is including 100 policies, then at the end, we will have like a 500 policies evaluating all resources, of course. If I don't have no resource, but I still have the initiatives here, that eventually will not generate any score or any recommendations because there is nothing to evaluate. The policies are there. The policies are active and trying to evaluate, but the lack of resources will make that, okay, there's nothing to compare and there is no result. You are, let's say, 100% compliant with all of the standards because you actually don't have any resource. But as soon as we are starting to creating resources on it, the policies are evaluating on a frequency automatically. So eventually we are going to see a change into the security score. And this is going to be a dynamic process as soon as we still have the initiatives turned on and active. Now, we are not just limited to the standards that we can see into the list for the built-in one. There could be organizations that they just wanted to follow its own custom initiative, and we have an option to create a new one. Now, in the process to create a custom initiative, we can just take existing individual policies and we can group together into one custom initiative, for example. If I need to follow my own 100 series of policies that comes from multiple built-in initiatives, then with this custom initiative assistant, I can group all those 100 policies together that I wanted to follow from the multiple ones, but I don't want it to follow a very specific one. Instead, I will create my own. Or I can create my own initiative from nothing and all of the policies if I do have the experience to do that. And if the organization wants to follow its own initiative and its own policies, not particularly stick to one of the standards one. Usually organizations will stick to a standard because of some legal or security requirements on it. but we are not just limited to use the built-in standards. So we can just create our custom one. But well, we need to know what we are doing it here. But basically, we just need to specify the policies, or starting to create the policies first and then group together into the custom initiative that we are trying to add. And we can remove the default, we can remove the built-in initiatives, and we can add our custom, for example. And now the evaluation and the score will be generated by the policies that we just add at the end, either the custom or the built-ins or a combination of both, for example. So that is how it works. So let's return to the presentation mode. So basically, as a cloud security posture management in Defender for Cloud, the posture management provides providers with visibility that will help us to understand our current security situation. And it will provide to us also a hardening guidance to help us to identify and effectively improve our security. So the central feature in Defender for Cloud that enable us to achieve those goals is the security score, the security score. So Defender for Cloud can help us to continuously assess our resources, our subscriptions, and organizations for security issues, and then aggregate all the findings into a single score so that we can tell at a glance that our current security situations. The higher the score, the lower the identified risk levels. So, and for the cloud workload protection feature, let's say, Defender for Cloud will offer security alerts that are powered by Microsoft Threat Intelligence. And it also includes a range of advanced intelligent protections for our workloads. And the workloads protections are provided through the Microsoft Defender Enhanced Security Features plans, specific to the types of resources in our subscriptions. As an example, we can enable Defender for Storage to get alerts about suspicious activities related to our Azure storage accounts. So because there's no need to have a plan for resources that we don't have or that we are not planning to create. And of course, that if I need to monitor our storage accounts, then I have the option to enable the plan for storage, and I can only pay for the CSPM and CWP feature, but for our specific type of resources on. So Defender for Cloud provides security alerts and also advanced threat protection for virtual machines, for relational databases or SQL databases in platform as a service, for containers, for web applications, for our virtual networks, and more. And when we enable Defender for Cloud, from the pricing and settings there for the environment options, the Defender plans are going to be enabled simultaneously, and it will provide us a comprehensive defenses for the compute, the data, service layers of our environment. So we can see in the list the Defender for servers, for app services or web applications, for storage, for databases, for containers, for key vaults, for resource manager, for Defender for DNS. And in addition, for defending our Azure environment, we can add Defender for Cloud capabilities to a hybrid cloud environment, including the on-premise. We can protect non-Azure servers, protect our virtual machines in other clouds, such as AWS and GCP, for example. A guided demonstration on managed cloud security posture, protects against the threats, and get advanced insights on it. Well, I just turned on the plan a few hours ago, yesterday actually, but well, I don't have many resources on it. I can just take a look at the security posture under the cloud security and see if we can find out some recommendations, but well, nothing there because well, I don't have like a lot of resources. I only have one virtual machine so far. So eventually, in the overview, we can see like a default dashboard with the number of subscriptions, the number of asset resources, number of active recommendations, and the percentage on the security posture on it. If we would like to see more details about this, we can just click on here to explore security posture, and then to be redirected to more details about how my subscriptions are detecting and defending for cloud in the plan detecting of some security and and trigger some security vulnerabilities, and what's the recommendation for that, and eventually looking at this scored in a percentage format from 0 to 100%. So Defender for Cloud provides a unified security management and threat protection also across our hybrid and multi-cloud workloads. Some of the prerequisites to get started with Defender for Cloud is that we must have a subscription to Microsoft Azure, and to enable enhanced security features on a subscription, we must be assigned with the role of a subscription owner, or we could be a subscription contributor also to have privilege, or a security administrator. Then we need to enable Defender for Cloud on our Azure subscription on it. And we can follow the steps to signing into the Azure portal. Then from the portals menu, we can select the Microsoft Defender for Cloud, and we can select the Getting Started option from the left and follow the instructions to enable the Defender for Cloud. Then Microsoft Defender for Cloud overview page will open, and it will start to visualize some information. On the next lesson, or lesson number 2, we can see how we can connect Azure assets to Microsoft Defender for Cloud. The asset inventory page of Defender for Cloud will provide a single page for viewing the security posture of the resources that we have connected to Defender for Cloud. So Defender for Cloud periodically will analyze the security state of our Azure resources to identify some potential security vulnerabilities. It then provides us with recommendations on how to remediate those vulnerabilities. And when any resource has outstanding recommendations, they will appear in the inventory. And we can use this view and its filters to address questions like which of my subscription with Defender for Cloud have outstanding recommendations, or which of my machines with the tag of production are missing a log analytics agent, for example, or how many of my machines are tagged with a specific tag have outstanding recommendations, or how many resources in a specific resource group have security findings from a vulnerability assessment service. And the asset management possibilities for this tool are substantial, and they are continue to grow also. What's auto provisioning? Well, remember that there is multiple types of resources that operate into different cloud service model. The two most common ones are the infrastructure as a service and platform as a service. An example of infrastructure as a service are virtual machines. An example of platform as a service, we can find it as a storage, databases, and so on. So when we're talking about auto provisioning, the auto provisioning is for an agent. The compute resources like Azure Virtual Machines, in order to report the information, because, well, I already explained to you how the cloud security posture management works, but the functionality for the cloud workload protection to detect some threats and trigger some alerts comes from the CWP functionality, the cloud workload protection, and how it is going to detect those kind of alerts, the Defender for Cloud, by monitoring their resources, for example, and taking a look at and capturing some logs and doing something with those logs, like detecting and identify some potential threats by monitoring those logs. So in order to start monitoring those resources and use the functionality of the CWP, there will be a need for provisioning an agent for these resources. Some other resources like Another example of a PaaS service is the an add-on for a Kubernetes cluster, because a Kubernetes cluster is not an infrastructure as a service; it's more like a platform as a service. Another difference between those two type of service models is that into a infrastructure as a service, we have better responsibility or higher responsibilities, because we are responsible for an operating system into those virtual machines and everything inside that operating system, the operating system version itself, the roles, the applications, the files, the volumes, etc. And into a platform as a service, the operating system is under the responsibility of the provider. For example, in a Kubernetes cluster, I don't even see that there is virtual machines there. Actually, virtual machines will be used, but those are under the control and under the management of the cloud provider. So just need to, I'm just responsible for the Kubernetes cluster as resource, but the compute nodes for that cluster, I don't even need to see it. I don't see it as resources on it. I can only see that I have a Kubernetes cluster with two, one, or multiple nodes. And every node is represented by an Azure VM, but I don't see and I don't own, and I'm not responsible for what happened to those nodes, basically. It is fully under the responsibility of the provider. So in that case, the provisioning process, uh, it is through a policy add-on to the Kubernetes, because actually there will be uh, not like an agent that I can distribute for that, because I do not have the control. The policy add-on will be an agent that will be installed to the cluster nodes, but I don't see an agent provisioning, for example, because it's not my responsibility. So data collection is only needed for compute resources, infrastructure as a service containers, and for known Azure computers. Remember that Defender for Cloud can also extend to other clouds and to the on-premise, and how the compute resources will report to the Defender for Cloud through the agent provisioning on. So there is automatic or auto provisioning from the Azure to Azure configuration, Azure VMs to Azure or to Microsoft Defender for Cloud. And there will be a manual provisioning process for the known Azure resources. If there will be an agent provisioning, but the computers are outside the Azure environment, then auto provisioning is not an option. Manual provisioning of the agent will be required on it. And that agent is an agent that will start collects some information and logs from those compute resources and from those operating systems, uh, and is they are going to report to a log analytic workspace. One of the required resources for the Defender for Cloud is a log analytics workspace, and the agent is the one that is going to connect to the log workspace for the persistence of the logs and for running the queries with the some built-in alert patterns for detecting some threats and some vulnerability issues, for example. So the log analytics agent, which reads various security-related configurations and event logs from the machine, and then it will copy the data to our workspace for analysis. And examples of such data are operating system type and version, operating system logs, including Windows event logs, running processes, machine names, IP addresses, and login users. A security extensions, such as the Azure Policy add-on for Kubernetes, can also provide data to Defender for Cloud regarding specialized resource types. And for the manual log analytics agent provisioning, to manually install the log analytics agent on Azure virtual machines or to non-Azure virtual machines, well, the auto provisioning is something that we can just decide to turn to off, because by default it's turned is turn it on. And we need to optionally create a workspace, a log analytic workspace. And we need to enable the Defender for Cloud on the workspace on which we are installing the log analytics agent. And we need to deploy the agents on the new virtual machines using a resource manager template and installing the log analytics agent on it. And finally, deploy the agents on our existing virtual machines. Now, where we can get that agent and how we can just configure that agent manually. Remember that the agent will be connected to a log workspace that will be associated with Defender for Cloud. But the log workspace is a separate resource. So if we look for the resource that is the log analytic workspace, we can access. I have one that I just called Sentinel-1 for the Sentinel service. The SIEM service, the SIM, requires also a log workspace on. So when we are looking at the log analytic workspace and the contextual menu, we can see how can we connect data sources to this log workspace. And when we can see, well, we can access through two different options, from the settings and then locating the agent management, or from the getting started with log analytics at the right and looking at the step number 1, connect data sources for Windows and Linux agent management. Clicking on each of the two options we will be redirected to the same place. And we are going to see, okay, are you planning to connect the agent for a Windows or Linux servers? So for the instructions here, you can download the agent from here, and then the agent will require this information like a workspace unique ID and one of the two keys for the authentication of the agent to the log analytics. And here we can copy these parameters, the workspace ID and the primary or secondary key on it. So this is where we can get the agent, the most recent version. And after downloading and install it, then we can specify this information to create that relationship basically. The log analytics gateway is when we have network control environments, we have maybe multiple computers or virtual machines, and there is no direct connection to the cloud that the agent can communicate to the internet to find out the Defender for Cloud. If that's the case, that we have limited internet access or control access, what we can do is to download a log analytic gateway appliance. We can download an OBA file or BHD file, configure it, import it, and then we can configure rule exception for the gateway. The gateway will collect with local private IP address access, collect all of the information for the other computers within the network on the destination, where the gateway will be deployed eventually. So this is how it works. And this is how we can perform a manual log analytics agent deployment. Next lesson is how we can manage cloud security posture management in Microsoft Defender for Cloud. Defender for Cloud continuously help us to assess our cross-cloud resources for security issues. And it then aggregate all of the findings into a single score so that we can tell at a glance that our current security situation. The higher the score, the lower the identified risk levels. And in the Microsoft Defender for Cloud overview page, the secure score is shown as a percentage value, and the underlying values are also clearly presented. So to increase security, it's a good idea to review the Defender for Cloud recommendations page and to remediate the recommendations by implementing the remediation instructions for each issue. So recommendations are grouped into security controls. Each control is a logical group of related security recommendations, and it will reflect our vulnerable attack surface And our score will only improve when we remediate the recommendations for a resource within a control. So to see how well organization is securing each individual attack surface, it's a good idea to review the scores for each security control. Defender for Cloud and its recommendations is based on the Azure Security Benchmark, which is the default initiative. The Azure Security Benchmark is the Microsoft authored Azure specific set of guidelines for security and for compliance best practices based on common compliance frameworks. And this widely respected benchmark builds on the controls from the Center for the Internet Security, or CIS. Microsoft is working in partnership with the Center for Internet Security, the CIS, and they are developing those security control of or best practices. And at the end, for every security control, there is an Azure policy or an entire initiative with the name of the Azure Security Benchmark on. CIS and the National Institute of Standard and Technology, the NIST, with a focus on cloud-centric security, and other recommendations are generated from regulator compliance initiatives. To view our recommendations, Defender for Cloud will start to analyze the security state of our resources to identify some potential vulnerabilities. And to view our secure score recommendations, basically we need to sign into the Azure portal, we need to navigate to the Microsoft Defender for Cloud, and then select recommendations. And here we will see the recommendation applicable to our environment. And recommendations are grouped into security controls. We can select the secure score recommendations. Secure score recommendations affect the secure score and are mapped to the various security controls. And the all recommendations tab allow us to see all of the recommendations, including recommendations that are part of different regulatory compliance standards. Defender for Cloud continuously compares the configuration of our resources with requirements in industry standards. So in regulations and benchmarks, so the regulatory compliance dashboard provides insights into our compliance posture based on how we are meeting specific compliance requirements. So how are regulatory compliance represented in Defender for Cloud? Some industry standards, regulatory standards, and benchmarks are represented in Defender for Cloud regulatory compliance dashboards. And each standard is an initiative defined in Azure policy. To see what regulatory compliance standards are available in Defender for Cloud, I already show you how we can access to the policy configuration in Defender for Cloud. By default, every subscription has the Azure Security Benchmark assigned. So this is the Microsoft authored Azure specific guidelines for security and compliance best practices based on common compliance frameworks. And examples of those compliance standards are the PCI, the SOC, TSP, National Institute for Standard and Technology, NIST, UK Official, Canada Federal PVMM, Azure CIS, HIPAA High Trust, SWIFT, ISO, New Zealand, and so on. Monitor workbooks provides a canvas for data analysis and for the creation of visual reports within the Azure portal. They allow us to tap into multiple data sources from across Azure, and we can combine them into a unified interactive experience. So within Microsoft Defender for Cloud, we can access the built-in workbooks to track organization security posture. And we can also build custom workbooks to view a wide range of data from Defender for Cloud or other supported data sources. So there's a workbook gallery in Microsoft Defender for Cloud that we can access. So with the integrated Azure Workbooks functionality, the Defender for Cloud makes it straightforward to build our own custom and interactive workbooks on it. So Defender for Cloud also includes a gallery with different workbooks ready for our customization. We can take a look at a security score over time workbook, track our subscription scores and changes to recommendations for our resources, system updates workbooks, view missing system updates, vulnerability scans of our Azure resource, compliance over time workbook. We can also view the status of subscription compliance with the regulatory or industry standards that we have selected. Active alert workbook, and we can view active alerts by severity, by type, by MITRE attack tactic, and location. Lesson 5 for workload protections in Microsoft Defender for Cloud. This lesson is including topics to explain which workloads are protected by the Microsoft Defender for Cloud, describe some benefits of the protection offered by Microsoft Defender for Cloud, and we need to explaining how Microsoft Defender for Cloud protection functions. So Defender for Servers. Defender for Server provides threat detection and also advanced defenses to our Windows and Linux machines or operating systems, whether they are running in Azure or into a separate environment like AWS or GCP, or into the on-premise. So to protect machines in hybrid and multi-cloud environment, Defender for Cloud uses the Azure Arc. Microsoft Defender for Servers is available in 2 plans: the Microsoft Defender for Server Plan 1 and Plan 2. Let's take a look at the Plan 1. The Plan 1 deploys Microsoft Defender for Endpoint to our servers and provide a series of capabilities. Like, for example, Microsoft Defender for Endpoint licenses are going to be charged per hour instead of per seat. And this will help us to lower in the cost for protecting virtual machines only when they are in use. Defender for Endpoint will deploy automatically to all cloud workloads so that we know that they are protected when they spin up. So alerts and vulnerability data from Microsoft Defender for Endpoint is shown in Microsoft Defender for Cloud. And when we go for the Defender for Servers plan number 2, or formerly known as the Defender for Servers plan, this includes the same benefits and advantages of the plan 1, and support for all of the other Microsoft Defender for server features. So to enable the Microsoft Defender for server plans, we can go to the environment settings and we can select our subscription. Then if Microsoft Defender uh, it's not enabled, we can set it to on. Plan 2 is selected by default. And if we want to change to the Defender for Servers plan, in the plan or pricing column, we can select to change the plan. And we can select the plan that we want and just select with confirmation, of course, that we need to be signed in with the proper role to perform these operations or these changes. Now, Defender also can be active for application services or web applications. So Defender for App Service uses the scale of the cloud to identify some attacks targeting applications running over the application service type of resource. So attackers will prompt web applications to find and exploit some weaknesses. And before that attack being routed to a specific environment, requests to applications running in Azure will go through several gateways where they are inspected and logged. So this data is then used to identify exploit and attackers and learn new patterns that will be used later on. So by using the visibility that Azure has as a cloud provider, Defender for Cloud will analyze a application service internal uh, logs to identify attack methodology on multiple targets. And for example, a methodology would include a widespread scanning and distributed attacks. And this type of attack will typically comes from a small subset of IPs and show patterns of crawling to similar endpoints on multiple hosts. So the attacks are searching for a vulnerable page or plugin and can be identified from the standpoint of a single host. So with the app service plan enabled, Defender for Cloud uh, assesses the resources covered by our application service plan and generates security recommendations based on its findings. Defender for X Storage is an Azure native layer of security intelligence that detects unusual and potentially harmful attempts to access or exploit our storage accounts. It utilizes the advanced capabilities of security, artificial intelligence, and the Microsoft Threat Intelligence to provide contextual security alerts. So security alerts are triggered when anomalies in activity occur. The security alert are integrated with with Defender for Cloud and sent via email to subscription administrators with details of suspicious activity and recommendations on how to investigate and to remediate some threats. Defender for Cloud for database security is another option. So allow us to protect our entire database state. So by detecting some common attacks, by also supporting enablement and threat response for the most popular database types in Azure. The type of protected databases are the Azure SQL databases, SQL servers on machines, open source relational databases, Azure Cosmos DB databases that will provide protection to engines and data types with different attack surface and security risk. Security detections are made for the specific attack surface of each database type on. So Defender for Cloud database protection will detect unusual and harmful attempts to access or exploit our databases on. So there is an advanced threat detection capabilities in Microsoft Threat Intelligence data that are used to provide contextual security alerts. Those alerts will include the steps to mitigate the detected threats and prevent future attacks. We can enable database protection on our subscription, or we can exclude a specific database resource type. Microsoft Defender for SQL will include two plans that extend Defender for Cloud data security package to secure databases and their data wherever they are located. So Defender for SQL comprises two separate Defender plans on it. The Defender for Azure SQL Database servers that protect the Azure SQL Database resources and the Azure SQL Managed Instance, and also dedicated SQL pool in Azure Synapse. So for other open source relational databases, Defender for Cloud Plan brings the threat protections for the following open source relational database: the database for PostgreSQL, database for MySQL, database for MariaDB when we enable this plan, and Defender for Cloud that will provide alerts when it detects anomalous database access and we query patterns and suspicious database activities. So Defender for Azure Cosmos DB detect potential SQL injections also. Known bad actors based on Microsoft Threat Intelligence, suspicious access patterns, and potential exploitation of our database through compromised identities or with malicious insiders. So we can enable protection for all our databases, which is a recommended option, or we can enable Defender for Azure Cosmos DB at either the subscription level or the resource level also. Defender can extend to resources like Key Vaults. Azure Key Vault is a cloud service that safeguards encryption keys and secrets like certificates on. Connection strings and passwords, we can store it into a Key Vault on it. Key Vault has its own multiple levels of access with access policies for controlling the access to secrets, to keys, and to certificate files, and the regular IAM roles, identity and access management roles, to control and delegate the access to the resource itself. One is to the control plane and other level of access for the data plane, for example. So we can enable Defender for Key Vault for Azure Native for advanced threat protection for Azure Key Vault, providing an extra layer for security intelligence. So Defender for Cloud detects unusual and potentially harmful attempts to access or to exploit the Key Vault accounts. And this layer of protection allows us to address threats without being a security expert and without the need to manage a third-party security monitoring system. So when anomalous activities occur, Defender for Cloud shows alerts and optionally can send them via email to relevant members of our organization. And these alerts will include the details of the suspicious activity and also including recommendations on how to investigate and remediate threats. Defender can extend for Resource Manager or ARM. Azure Resource Manager is the deployment model that Microsoft Azure is using. All the time that we're using the user interface, the Azure portal, Cloud Shell, and so on, we're making a request to the Azure Resource Manager deployment model. So Resource Manager is the deployment and management service for Azure. It provides a management layer that enables us to create, to update, and to delete resources in our Azure account. And we use management features like the access controls, the logs, and tags to secure and to organize and to manage our resources after deployment. So the cloud management layer is a crucial service connected to all of our cloud resources. Because of this, it is also a potential target for attackers. So we recommend security operations team to monitor the resource management layer closely. Microsoft Defender for Resource Manager automatically will monitor the resource management operations in our organization independently of what are the tool that we are using, because at the end, any of the supported management tool are calling the Azure Resource Manager. Either if we're using the Azure portal, REST API calls, Azure Command Line Interface or CLI, Cloud Shell, or other Azure programmatic clients. So Defender for Cloud runs advanced security analytics to detect threats and to alert us about suspicious activity. There is a DNS private and public zones that we can use into our Azure subscriptions to map um, records to IPv4, IPv6, to CNAME to canonical name records, and so on. So Azure DNS is a hosting service for DNS domains that provides a name resolution by using Microsoft Azure infrastructure. So by hosting our domains in Azure, we can manage our DNS records by using the same credentials, by using the same API, the tools, billing, as or other Azure services. The Microsoft Defender for DNS provides an extra layer of protection for our cloud resources by continuously monitoring all DNS queries from our Azure resources and for running advanced security analytics to alert us about suspicious activity. So Defender for DNS protects against issues including data exfiltration from our Azure resources using DNS, for malware communicating with a command and control server, communication with malicious domains as phishing and crypto mining, DNS attacks, and communication with malicious DNS resolvers. Defender for Containers is the cloud native solution for securing our containers. Defender for Containers comes with some features on it, like environment hardening. Defender for Containers protect Kubernetes clusters, whether they are running on the Azure Kubernetes service environment, or if we have Kubernetes on the on-premise or built into an infrastructure as a service into a virtual machines, or into Amazon Elastic Kubernetes Service, or EKS. By continuously assessing the clusters, Defender for Containers provides visibility into misconfigurations and guidelines to help to mitigate identified threats. We can find out that there is a vulnerability assessment for containers on it. So vulnerability assessment and management tools for images will be stored into an Azure Container Registries and running in Azure Kubernetes Service. In order to pull and push images to the running container services in Azure, we need a container registry service. A container registry can be public or private and can be internal in Azure or external one. So a container registry will be like an storage service, but specifically for container-based applications. And a service that is considered a private and internal for Azure as a resource is the Azure Container Registry. Azure Kubernetes Service, Azure Container Instance, Web App for Containers can be integrated with Azure Container Registry. So Defender for Containers protect our clusters, whether they are running in Azure Kubernetes or into a Microsoft managed service for developing, deploying, and managing containerized apps, or into an Amazon Elastic Kubernetes service in a connected Amazon Web Service account, or into Amazon managed service for running Kubernetes on AWS without the need to install, operate, and maintain our own Kubernetes control plane or nodes. An unmanaged Kubernetes distribution that is using Azure Arc-enabled Kubernetes, and a cloud-native computing foundation certified Kubernetes cluster hosted on the on-premise or in infrastructure as a service virtual machines. This module 3 comes with one lab, Lab 01, to mitigate threats using Microsoft Defender for Cloud. The lab tree comes with two main exercises. First, you are going to follow instructions to enable Microsoft Defender for Cloud, and then with the task or the exercise number 2, you will mitigate the threats using Microsoft Defender for Cloud. I will show you just a quick introduction to the lab, guys. My recommendation would be to start loading your lab. Remember, you access to the virtual conference manager, you access to the resources link or tab, and you will find out the URLs to join to the session that you activated yesterday. Once that you are able to find out our class for SC200 and the lab exercise, you can click on launch like yesterday to recover your progress. Remember that there is only one lab session, but there is multiple modules and exercises built into the same lab session on it, because some lab exercises for or lab platform for other courses or other classes like this has its own module separated from the lab session. So you will find out like multiple launch buttons into the previous list for each of the module labs. In this case, there is only one launch, but into the same instructions are built in as you are moving on to the next pages, for example, for the instructions. For some of you that are asking for the lab instructions are built into the lab when you're clicking on launch. Remember that there is two sections. The section at the left, that is the virtual machine that you are operating, and the right section where the instructions and the list of resources are listed here. So you can separate this if you have a dual monitor option by clicking on this little upper right corner menu. You can save your lab from here. You can mark your lab to end, or you can click here to split the windows. In the split windows, you can take this to your second monitor, put it there into full screen mode like this, and you can see the entire instructions here. Now, if this is not enough, the labs are actually hosted into a public GitHub repository. So you can make a search like SC-200, and you can start writing GitHub, and you will find out the repository. The repository of the SC200 Microsoft Security Operations Analyst, you can find out a subfolder for instructions. You can click on it, you can click on the subfolder for labs, and now you will find out all of the exercises. For example, if we are into the 03 for module 3, exercise 1 to enable Defender, you can click on the .md file, and the instructions are here also. Nothing special. The URL is a difficult one to remember, but you can just make a search, like in my case, SC200 GitHub, using Bing, using Google, we're using any other search engine, and you're good to go. You can save it as your bookmark, and you can keep it for as long as you need it. Now, well, if I don't want it to just, well, I can join the windows again, and I can return to my original state, right? So if you're already finished with the modules 1 and 2 exercises, following the progress from yesterday's sessions, then you can click on next to move on now to the module 3, lab 1, exercise 1, to enable the Microsoft Defender for Cloud. It's a good idea to take a look at the diagram of the expectation of this exercise. Like, for example, it says that with 5 different tasks, you will access the Azure portal and you will set up a subscription. That you will create a log and a workspace as a resource. On the task number 3, you will enable Microsoft Defender for Cloud. That will be associated with that log and a workspace that you create previously. On the task number 4, you will install Azure Arc on an on-premise server. And then on the task number 5, you will protect an on-premise server. So basically, what you are going to do is to create a workspace, a Defender for Cloud link to that workspace, and activate the plan. And then you are going to test a couple of services. A Win server virtual machine, where you are going to deploy the agent for the log analytic workspace, and to be able to Defender through that agent to monitor the status of that Win server. And because the Win server will act as an on-premise server, you will install the Azure Arc that will be for extending the administration with the Azure Arc to your virtual machine, like if it is an Azure virtual machine, but that is actually living in some other place, like an on-premise or a simulation of the on-premise, basically. Okay, so you can follow the instructions from there. When you're finishing with this one, you can click on next, and you will find out the exercise number 2 to mitigate threats using Microsoft Defender for Cloud. Now, the diagram is so simple here. In this case, actually with one task, you will use Microsoft Defender for Cloud for checking in or simulate to trigger a security alert, and you will find out a sample alert. So you can read the context for this lab exercise. You are a security operations analyst working at a company that implemented Microsoft Defender for Cloud, and you need to respond to recommendations and um, and security alerts generated by Microsoft Defender for Cloud. Guys, recordings will be available on the next 5 to 10 days after the session. The recordings are not that immediately available, okay? So you will be able to access from the virtual conference manager, but after the 5 to 10 days. All right. This is the end for this module 3, and we have another module to cover for the remaining 48 minutes on it. So give me a second to start loading the module 4, and I will set it to presentation mode. Just give me a minute to drink a little bit of water. Okay. The next module, number 4, we're going to see how to create queries for Microsoft Sentinel using custom query language, or KQL. Lesson 1 stands for construct KQL statements for Microsoft Sentinel. This lesson will include topics like constructing KQL statements, search log files for security events using KQL, and filter searches based on event time, severity, domain, and other relevant data using custom query language, or KQL. Okay, before this, let's try to just bring all of the elements or the pieces here instead of going straight to the KQL. Remember that we are using a log analytic workspace. And specifically, we're going to, well, let me just try to open a whiteboard here to draw something. Remember here that we are just using log analytic workspace integrated with Defender for Cloud. However, in this module, we're going to start looking at a log analytic workspace associated with the Sentinel service. The two services, the Defender for Cloud and the Microsoft Sentinel, requires a log analytic workspace. Sorry, this is for a different session, but well, let me use an empty space here. Now, we have log analytics as a resource. Sorry, I just made a mistake here writing. Log analytics. And then this is a repository of logs or events or data, for example. But we have Defender for Cloud. And also we have the Microsoft Sentinel. Defender for Cloud, yes or yes, needs a log analytics repository and also Microsoft Sentinel. Now, in this module, we're going to see an association between Sentinel and log analytics. Sentinel is a service that is representing a security information and event management, security orchestration and automated response, and extended detection response, like a 3 security tools built into one. How it works? Well, we can create the Microsoft Sentinel as a resource. The Microsoft Sentinel requires a log analytic workspace. And once that the two are connected, using the user interface of the Sentinel, we can access to the log analytics repository. But we need to start connecting the data sources. If we don't have data connections, then there is nothing ingested to the log analytic workspace. So the log analytic workspace is like a big database that it has a schema, and inside there's multiple tables inside the log workspace. There will be a schema with multiple tables. Those tables will be, for example, I don't know, the anti-malware information. It could be another table for events. It could be another one for, I don't know, information about databases, for VNets, NSG low logs, for example, and so on. So as soon as we are connecting more information to the log analytics from the Sentinel service, more tables are being added to the schema. And because log analytics can outscale with the service, virtually doesn't have any limitation on it. So virtually any resource that we can connect or any data connector that we can find out into Sentinel can be connected. And multiple data types or multiple tables will be pre-configured with that data connector. So one connection can represent one or multiple tables for it, because it will include multiple data types. So all this information is being delivered into the log workspace. So how we can visualize the information for all this? By running KQL queries. So from the, let's say, the query editor or engine, which is represented by a user interface, we can run KQLs. custom query languages. And those custom query languages will have an output on. And that output usually could be into table format with different rows and columns with information. Also, we can work with operators. This could be one output from one of the KQLs, but this could be another KQL result using a render operator to generate graphic information, for example, or to use another render to use some sort of a pie chart, for example, with percentages or something like that, or using it to display columns with different colors and different scales. So we can just create and edit and construct the queries, the KQLs, to display the information that we want. And now the combination of these multiple KQLs, we can group together to create a canvas like this, and then we can create a workbook. A workbook here that I can consolidate these 4 KQL results. Okay, so returning to the presentation. The custom query language statement structure. A KQL query is a read-only request to process data and to return results. What data we're processing? The data that is into the log workspace. And what data we're importing or connecting to the log workspace? The data from the Sentinel service, for example, through the data connectors. So the request is stated in plain text using a data flow model designed to make the syntax easy to read, to write, and to automate. The query uses the schema entities organized in a hierarchy similar to a SQL database with tables and columns. It is important to understand that how the results flow through the pipe, this little pipe that we can see here, because this is like also working with PowerShell commands, for example. The pipe are used to separate operations, let's say. When we are running a query calling the name of a table, like the security event, we are retrieving the data into its original format with no filtering. And this will be how the result for running this section of the query, just calling the table, will look like with all of the records, all of the historical records here listed. But using the pipe is we are taking this raw information as an input to the next operation. So the output here is moved as an input after the pipe to the next operation. And using other operators, now we can start processing the data that we just take as an input from the previous output. So this operator to where is where we can start filtering, where the event ID. Now here, for all these columns, we'll have a name of these columns or a parameter. One of this, like this, for example, this could be representing this event ID. So in this case, into this column, within this where operator, it is going to search for a value equal to 4626. A 4626 event ID is usually a logon event. So the query should be something associated to a sign-in event from a user or a principal. So let's say that from the entire column, find out a match into the record number 2, and let's say 3, 4, 5, 6 into the record number 6. Here, there is 2 records that matches with the event ID exactly equal to 4626. So instead of now continue working with the whole result, after the where with the filter and matching the conditions on this, well, in this case, there is 5 records founded. Now I have a result that is more refined or more filtered, but this is not the end of the query because I'm using another pipe. Now, within this new filter output with my 6 or 5 records, I'm taking my 5 records as an output, and after the pipe to passing that output as an input to the next operation to continue processing the filter data, but in this case, summarizing and count by account and so on. So in this case, it is reorganizing the results and is going to start counting by another parameter that is an account, and is going to count how many events for the 4626 for a single account. So let's say that I have an account that is for a user 1, the user that you just create yesterday, I don't remember where. But let's say that this user 1 has like a 3 events equals to 4626. So I will expect to see as a result that, okay, user 1 has 3 events for the 4626. And I can see there's 3 records with the timestamp and with all the same information on it. But I'm just filtering and reorganizing the data because a part of the user 1, maybe I can have a user 10 reporting another 2 events of the 4626. So now my 6 records are representing 2 users, and with all these signing events. Now, sometimes it's also a good idea to specify a time range, because if I'm not specifying a time range, then I basically, by default, representing an output that is retrieving all of the historical records on it. So for user 1 and 10, maybe from the last 24 hours, are reporting these 3 and 2 logon events. But because I didn't specify a time range on it, I will expect to see more records because they are looking at the same condition for user 1 and 10, but when they are reporting 4626 events, and if these users are signing in and signing out on a daily basis, of course that I will see historically a lot of records, hundreds or maybe thousands of records with these logon events on it. So if I'm looking for something really specific to a time range, we can specify other filters to use a specific time range, for example. At the end, after we have the data reorganized by account, the output is passing as an input for the last pipe, and we are limited this information to 10. So in the event that I'm not specifying a time range, the default raw data is ordered by the most recent events. If I'm limited to 10, then it doesn't matter if I have 1,000 records for these 2 users. I would like to see the last 10 and the most recent 10 events, for example. So I can see maybe for user 1, user 10, or user 20, for example. But I will only display 10 records. It will be the most recent ones because I'm not specifying a time range on it, for example. On it. So that is more or less how this KQL works, for example. On it. So, and we are using multiple lines into the KQL editor to write these one or multiple lines to processing, filtering the information that usually just by calling table names, we are retrieving raw data only. We can take a quick look also to the portal. Well, this is the user 1 signing in, but I should have another account here. I already have a workspace that I just call Sentinel-1 because it's already connected to the Sentinel service, but I can access to the workspace as a standalone service. So when I just wanted to see it into the general, I can click on the logs option to open the log analytics user interface. Then I can see that there is a list of built-in queries that I can start testing, for example, like the top 3 browser exceptions. I can click to load to the editor. The editor is this. The first 2 lines with this double dash are just comments, and the comments are usually displaying the purpose and objective for this built-in query. The line 3 is including the name of the table, or the name of the name of the table that we are querying. And the next lines are including the pipes to use operators like where, summarize, top 10, and so on. So after I just click here to run, the query is running. But of course, that if I don't have the data source connected yet, I will not expect to see any results from there, for example. So, but well, the schema is here. Also, I can search for a common, for example, data source. Like I already have a, well, for security, let's say, let's take a look at the accounts failed to log on, for example. Double clicking on it, selecting, and see, click to run, and see if we have some results. No result found from the last 24 hours, so try to use a different um, time rate. But well, my subscription is pretty new and I don't have so many resources on it, so this is going to be difficult to find out a built-in query for that. Maybe with the Azure Monitor service, auto scale fail availability rate, daily calls, hourly calls, participants, round trip stream per call. For Azure resources. Huh. This thing is not responding. Well, let's continue with presentation on. Now, for other operators, we can use the let statement, like the one that we're looking here. Let the time offset, let the discard event ID, and so on. And now this is a name of a table, and there these are pipes and multiple operations on. The let statement is to set a variable name equal to an expression or a function or to create views. In this case, we are creating variable called time offset equals to 7D or 7 days. We're temporarily storing a value with this let statement, like declaring a variable. And that discard event ID, which is another variable, with equals to a 4688. 4688, it's representing a new process that has been created, for example. So we can use the let statement that are useful for breaking up a complex expression into multiple parts, and each represented by a variable. We can define constants outside of the query body for readability, and we can define a variable once and using it multiple times within a query, just by calling that the variable name after we just define it at the beginning, for example. In this case, these other operations with the ago and something between parentheses that will take the current date and time and will subtract the value provided. In this example, the time offset and discard event ID are created and used as part of the security event where clause. Let the where summarize are representing operators, while the equals, double equals, major, and less than, and the are representing expression. Same to the not equals to, with this expression of the closing exclamation mark and the equal that is basically representing a not equal expression. While time offsets, time generated, discard event ID are property types, for example. Other operators that we can use are the search operators. In this case, the search operator will provide a multi-table and multi-column search experience on. We can use the search to find data when we are unsure which table or column to filter. The first statement will search for ERR across all tables when we are looking for errors, for example. And the second statement will search for ERR in tables, but not into specific tables on it, like security events, security alerts, and all of the tables that starts with an A. Comma separated values, and we can use a function here with a wildcard or an asterisk. If we remember a table name that starts with an A, but we don't remember the name of the table, so we can use this operator like, okay, separated by a comma, it starts with an A, uppercase, and then an asterisk, and it will retrieve all of the table names that start and that match that condition. Start with an A and everything next. A uppercase and everything next. Could be one or multiple characters. And it's searching for the term error across these many tables. If there is a matching condition for this A and the asterisk for other 3 tables, then we can see the result for 3 tables and the other 2 that we just previously defined, security event and security alert. And if using this operation at the beginning, then we're searching across all of the tables on it, in this case. So if there is like 100, well, searching into the 100. The higher the scope, the longer that the query will take. Will take more time, maybe, for example. The more that we'll filter, the quicker that the result is presented. Using the where operator, the where operator filters a table to the subset of rows that satisfy a predicate. In this case, we are using multiple examples. Calling a security event table, one pipe to where the time generated is major than or longer than a day ago. So we can specify a time range here. I'm looking at security events, but no longer than 1 day, no longer than 24 hours ago. Or we can use another example, calling the security event table where the time generated is longer than an hour ago. And in this case, with the event ID of 4624, equal to 4624. 4624 event ID is equals to a successful logon attempt. So, because here we're using like a 2 conditions. First, the time generated, no longer than an hour ago. We have a pre-filter here because the event ID will only search from the events or the records that are matching this condition. And I will not expect to see results that are not matching that condition on it. So I'm using like a 2 conditions with 1 pipe because I'm using the end event ID, for example. In this case also, I can use, we can see another example where there is calling an entire table security event like the previous 2, but we're using multiple lines and multiple pipes where the time generated is longer than an hour ago. So we have an output here. But because we have different pipes, now we're processing this output and pass it as an input to the next line. And where the event ID is equal to 4624. So right now we're taking all of the events that matches the an hour ago. And after having those records for the hour ago, now we're searching through those records for the hour ago and looking for an event ID equals to 4624. And at the end, we are taking all those that matches the 4624. And when we are looking where the account type on one of the columns or one of the parameters or properties are, in this case, equals with no case sensitive to everything that matches under the under these 2, I just forgot the name for these characters on it. But well, everything is inside of this, the user, for example, and no case sensitive. That means that it could be on upper or lower cases on it. So this expression, the equals to and this symbol is representing equals, but with no case sensitive. It doesn't matter if it is uppercase, lower cases, or a mix, for example. And in the last example, we are calling the same table using the pipe with the where operator, event ID in, and we are looking with two possibilities, 4624 or 4625. And if there is a matching for all those properties, then we will see a result with these two event IDs, not just for looking for a specific one, but looking for two possibilities. That the other 4625 should be an event ID associated to a log in or log out event, for example, because the 24 is a successful login attempt. Maybe the 25 is a not successful, for example. Not so sure, but could be. Using extend operations or operators, the extend operator will create calculated columns and will append the new columns to the result set. So the KQL example below uses the extend operator to create a new column, start there, containing the directory and a process was started in. The started column is a calculated column containing the result of a substring function. Then we can use projecting or project operators, and there's multiple of them. Project, project away, project keep, project rename, project reorder. Using the project is to only present into the output certain values from the original output. Using the project, we can specify to only display me as the output some parameter, some property, for example, and hide the others. The result is still there, but using the project, I would like to see only this. Or depending on the type of project operator that we're using. The project is select the columns to include, rename, or drop, and insert new computed columns. Project away is select what columns from the input to exclude from the output. Projecting away, for example, is I don't want it to see the event ID column. It's still there as a result for the query, but I don't want it to see it. Project away is just excluded from the output. Project keep is select what columns from the input to keep in the output. Project rename, select the columns to rename in the resulting output. So maybe the default property value for that column, it is not something that you would like to see. Maybe it's going to be more clear if you could see that value with a different name. So you can use the project rename. And now when you're exporting or visualizing that result on a workbook or on a report, then maybe it's more clear for the people that is going to read or that is going to generate it. Project reorder can set the column order in the resulting group. So the project operator controls what columns to include, to add, to remove, or rename in the result set of a statement. And there are multiple types of project operators. Next lesson is for analyzing query results using KQL, Custom Query Language. Two topics into this lesson. The first one is to summarize data using KQL statements, and the second is for render visualizations using KQL statements. The count operator, with its variations, will create a new column with calculated results for the specified fields. For example, the following statement that we are looking as the example at the left is a rule that will help us to detect some MFA, multi-factor authentication failures across multiple applications for the same account. The where operator for result description will filter the result set for results that includes the MFA. Next, the statement will summarize, will produce a distinct count of application names, and will group by user and IP address. And finally, there is a check against a variable created or threshold, variable created with the name of threshold, to see if the number exceeds the allowed amount, for example. And usually, if it exceeds, there could be a policy that after failure attempts to sign in with a user with an MFA, the account can be temporarily blocked, for example. So maybe with this query, we're looking at recently locked accounts because of MFA failures, for example. Then we can use operators for summarizing. For summarizing, we can use an argument max or arg underscore max and argument minimum or arg underscore min with open and closing parentheses after that. So, and some value inside on. This function will filter out top and bottom rows respectively. The arg max function, for example, the following statement will, the one on the top, will return the most current row from the security event table for the computer with the name or with the fully qualified domain name of sql12.na.contosohotels.com. The asterisk or the wildcard after the time generated and separated by a comma inside the argmax function will request all columns for the row. Remember that the wildcard usually includes anything or anything into that range. And the next, the arg minimum will return the older current row with the arg min, for example, by computer and where the computer name is sql12.na.contosohotels.com. Just by taking a look at the name of the computer that we are looking for, we can identify its purpose. SQL12 should be a computer with a SQL Server instance on it, hosting one or multiple relational databases, for example. We can also use some other summarize operators like the make underscore functions that will return a dynamic JSON array based on specific function's purpose. The function will return a dynamic JSON array of all the values of expression in the group. And this KQL query will first filter the event ID with the where operator, and next, for each computer, the results are a JSON array of accounts, and the resulting JSON array will include duplicate accounts. And into the next query, the one at the bottom, the make set, the make underscore set function will return a dynamic JSON array containing distinct values that expression takes in the group. And this KQL query will first filter the event ID with the where operator. Next, for each computer, the result are a JSON array of unique accounts. And render operators. We can use the render operators to create or modify the default visualizations on an output. So usually this is used as a final operator, for example, when we want to present the information into one of the different visualization options. So the render operator generates a visualization of the query results. The supported visualizations are area chart, bar chart, column chart, pie chart, scatter chart, time chart, and so on. So depending on the operator for the render, we can see a different way to view the same information. For example, we can take an example from here, but well, instead of using my subscription like yesterday, I just show you we can access to a demo environment. This demo environment, start log analytics, log analytics interface, log analytics tutorial. I don't think that is this one. Or yes, demo environment here. You can sign in with any account. It will open the log workspace connected to a public one. So here I will take a look. I will copy and paste the examples of this. For example, here. This is one of the examples from the slide. If I'm just selecting the table name and clicking to run here, I will get as the output all of the security event table. So the longer the time that the query takes is because there is a lot of records on it. So actually just get to the limit, the first 30,000 results, for example. And the default format is using a table format where we can see all of the column or all of the properties. There is multiple of them. 30,000 records are displayed. So there's too many. But well, if we run the query, not just calling the table name, the entire query, we can see different results. Summarize, count, and by account, and these are the account names, and render as a bar chart. So on the top, it is displaying the account that is reporting the highest number of events, of security events in this case. And these are from the NT authority system. And this is why the graphic is not just too easy to read, because there is a big difference into the number of events from the NT authority system that is reporting 148,361. And the next one is just a 26,000, while others are just with a couple of thousands, couple of hundreds, and just a few events, for example. So the scale and the visualization that I have is not just working. So this would not be the best way to display this information, for example, because there's a lot of data and a lot of events. But well, modifying from area for bar chart to area chart is the other convenience is that this is context sensitive. When you're writing something that is actually that you're writing it right, it will recommend you to use, and you can just use the tab. This is to avoid making mistypes on it. This is a separate format, a different format. Column chart, for example. To see it in a different order. Different way to visualize it. Pie chart, maybe. Run it again. You can see it and distribute it automatically into the separate colors. Scatter chart. Run it again and see. Just with little dots on it. And time chart at the end. Yeah, a little bit different on it. So let's use the second example from that slide. In this case, it's summarizing by count, but by the time generated and for a time span of 1 day, and rendering to a time chart. The same format as this, but I will see maybe different number of events that specifying here to a line from this one. So, and you just see that at the time that I just run it, because I'm using more filtering, displays the data really, really quick. All right, guys. this is the end of this module. Well, uh, at least the part that I'm partially covering. Remember that you have some topics to from homework that I will into the Q&A session. I will present those topics that you need to take as your homework. Okay. The module 4 lab, there's only one lab exercise. You are going to create queries for Microsoft Sentinel using custom query language. So you will start practicing actually with KQL. So there is only one exercise, creating queries for Sentinel using custom query language. Let's take a quick look at that lab. We have 5 minutes for the end of this session. Remember that we will take a 30-minute break. After 30 minutes, we're connecting to the lab and Q&A link, and then you're going to work into your lab exercises and you can ask your questions. Give me a second here to return. Where is my lab? It's here. Okay. Now, after clicking here on for going to the next one, so for this module, this is the lab scenario and expectation. With an existing demo log analytic workspace, you will use multiple tasks from 1 and up to 6 to mitigate some security alerts, run basic KQL statements, analyze results in KQL with the summarize operator, create visualizations in KQL with the render operator, build multi-table statements in KQL, and you are going to work with string data in KQL. Here, you basically are going to copy and paste. Usually, for example, when you are already logging to the portal, well, maybe you are going to join to the demo environment, like in my example, by clicking here to paste it into the Microsoft Edge. This will open the demo environment, and into the demo environment, you're starting to, okay, here, just click on the T to paste it into this, and then to run the query to display the security events. For example, there will be multiple of them because I already run this query, but into my computer. But at the end, I'm querying the same demo environment, so the same number of records. It will get to the limit of the 30,000, for example. But well, if I wanted to be more specific, then I just paste the new query, wait until it finished pasting everything, and just clicking here to run. And you should see your result eventually on. So you're going to practice with all this KQL, read all of them, make sure that you're understanding what is the operator objective, if you can see it, and then until you finish with all with this lab. So you will work today with the modules 3 and module 4, basically. 2 exercises for module 3, 1 exercise for module 4. For the ones that are still having problems by accessing to the lab, remember that you need to access to ask for support into your same virtual conference manager, and with the links for asking for support, you will find a form or a URL that you will create a ticket on it, because these, for some reason, the SC200 yesterday were reporting that a maximum capacity for the labs, because, well, multiple sessions are running at the same time, and the capacity, for example, are for 300 students. So there should be, at least for the enrolled users, 87 active codes, let's say, for the attendees. But for some reason, something happens on it. And usually this happens with these massive events. But some of you already reported yesterday that just by creating a ticket with a URL helped the situation, that somebody just activated for you, or they provided you with a lab key. Because the lab key that you received from support, based on my request, they're just sending me an individual key that some of you already use, and that's all. I was thinking that it was a multiple lab activation key, because usually that works that way, that they're just providing a key with 50 activations for 50 users, and everybody can use it. But actually, the one that somebody provided to me yesterday was limited to 1, because maybe just somebody just took my request. Oh, this is another request like for any other guy, and that sending the lab key, and with the lab key, just activate it. Okay, guys, thank you for your today's session. Remember, we are taking a 30-minute coffee break, and we are returning to the lab Q&A with the corresponding link for that session on. Into that lab and Q&A, I will present the image with the pending modules that you need to take as your homework on. And you will work with your lab exercise, okay? Thank you, guys, and see you in 30 minutes.